To find a graphical solution to this system of differential equations, I'm going to use the command vector plot. Okay, so what I want to do is first define each equation. So my first differential equation, x1 prime of t, is going to be this value. So here I'm defining the system. This command I'm using to find the equilibrium values. So I'm setting the first equal to 0 and the second equal to 0, and I'm asking at what time do you have a 0 rate of change for the system. And then this is my vector plot, which I'm plotting both equations from my system of differential equations. This is my range. Stream points is my initial condition. Okay, and this will plot a red line on my picture. Okay, and then the rest is just graphical things. So as I run this, this is my equilibrium. Okay, so this is the output from this line, finds the equilibrium values, which are 0 and 0. And that makes sense because the initial plot we had showed convergence to 0 very rapidly. So no matter what initial condition I pick, it should all approach 0. And as we look at this picture, you can see that in fact it does approach 0 very quickly. All the arrows are pointing towards the origin no matter which way we come from. So my initial condition was 2 and 4, which if I put a dot it would be right about there. And the red lines pass through the dot and it goes forwards and backwards of that dot, but it shows if I were to drop say a straw in a stream of water, which way is it going to flow? Well, it's going to flow to the center and stop. It's convergent. Okay, if I change this like I did in my example before and I take that negative off, then that's going to make this system diverge very quickly. And I have errors here. Those errors are associated with just the kernel in Mathematica, so I can run this quit command in the top line separately and rerun this box, and that should get rid of my error messages. Okay, so now I've changed this to be positive, in which case we know we're going to get a positive eigenvalue, which should make the system diverge. So in which case the equilibrium is still at 0, but it's an unstable equilibrium, because if I pick anything close to that equilibrium point, it will quickly diverge and go off to infinity in a different direction. So here's my same example where I had 2 and 4. Okay, and you see it's diverging. So if I try to pick something that's closer to the origin, you'll see that it still will diverge. And I can plot more than one initial condition in this stream point command by just adding, let's do -1 and -1. Okay, so this is the beginning of the stream point command. This bracket denotes the end, and the two values inside are two initial conditions I want to plot. And that shows the behavior of each initial condition graphically.